NFT collection at scale. But first, hello everyone. Zdravo, as you may say. My name is Marius, and together with my colleague Vlad, we will present you how we scale NFT collections. But first, a bit about us. Thank you. We work as technical leads for Sandbox, and we also co-founded a software company called QED, which was trusted by Sandbox to get things to the next level. We started almost 2 years ago. We started as a team of 4 developers, and now we are over 25 developers and designers. Our office is located in Romania, in the city of Timișoara, which is also the cultural capital of Europe this year. And if you visit, feel free to reach to us, and we can show you some cool places. Cool. So a bit of context. We started working on Sandbox on the Snoop Dogg collection called the Doggies. I wonder who's familiar with Sandbox around here? Oh, that's pretty great. Yeah, so we started with this collection, which was a real hit, and with the increase of the popularity of NFT collection, we got also the demand for NFT collection grew. Also, we had to integrate pre-existing NFT collections such as Bored Ape or Clonex into the Sandbox ecosystem. Of course, our tooling were not capable to handle that level of demand. And from one collection every 2 other months, the demand increased to 4 collections per month. And we had to upgrade our tools. This presented 3 major issues. So first, let's try to define what an NFT collection is in the context of Sandbox. In the context of Sandbox, an NFT collection is built from 3 parts. One is the web application, the second is the smart contract, an ERC 721, and we have the art integration, which is the process where we map the token ID to the art in the ecosystem. Vlad will give you further detail really soon. For each of the components, we managed to identify bottlenecks. Cool. So first one was the web application. And in the context of Sandbox, the minting the app or the web application is made from 2 parts. One is the landing page, and the second is the minting page. Of course, the minting page is used by the user to mint, but the landing page is used by the marketing to highlight the utility of the collection, also to promote it. So this needs to be custom-made. It should follow the brand and the client looks and feels. Like they need to have the colors, the fonts, and so on. Creating more and more collection, we begin to identify recurring design patterns and mechanics into our application. As you may notice on the slides, most of our collection follow the same structure, so it has the same layout. To speed up the development, we're creating a small component kit, some sort of design system that can provide us mobile-ready and accessible components that can be used to build minting web applications. So after we integrate this and we managed to speed up the development, we were still not happy. As we were a part of Monolith, the Sandbox dashboard Monolith, which is an old application with a lot of legacy, and of course it has his own release cycle, which is very lengthy. So even though now we can create web applications really fast, we still need to wait for the release cycle of the monolith. So in order to fix that, we created a micro front-end architecture. So we extracted all the NFT collections into micro front-ends that were independent and autonomous, so we can deploy every time we want. They are built into static files, so you can deploy on IPFS, S3 buckets, and so on. Okay, now that we can create and deploy a faster application, the only thing that we had to do was to duplicate some code, change some styles, change the contract name, apply some copy, and we were done. But that's not really fun, and doesn't scale in the real world. So that's why we created this tool, which we name it Create Sandbox Collection, which is a CLI app that can bootstrap a sandbox web application in like seconds. Cool. So now that developers were happy, we can create and deploy NFT application as much as we want. The users were not quite there. So we place great emphasis on analyzing the user behavior on the minting phase. And based on that data, we managed to identify some pain points. One example was the transaction history. So for some context, in the early days of Sandbox, the contracts were deployed on the mainnet. The demand was really high and people wanted to just mint. And the network got busy as well. In this case, a user tried to mint an NFT. They see a loading screen, but because the transaction resolution was really lengthy, they didn't know what happened. They refreshed the page, and they see the mint box again and the button. And they tried to mint again. That resulted in faulty multiple mints. To fix that, we implement this feature, which is a transaction history list, where you can see all of your transactions on the contract with real-time status. For example, you can see if the transaction is failed, and if you have a pending transaction and you refresh the page, you will see a really nice warning that will tell you that you have a pending transaction. Another pain point was error management, as we use two tokens when we mint, one to pay the gas and one to pay for the NFT send. So if you were on the wrong network and you didn't have enough funds, you will see first the wrong network error, and after you fix that error, you will see that you don't have enough Matic to pay the gas, for example. To fix that, we just display the errors in line there. Also, I'm really happy to announce that we will support gasless payments really soon, probably around this summer. And also, we are experimenting with credit card payments to make the onboarding of Web2 user into the realms of metaverse easier. Cool, so now that the problem of web application was fixed, we had a problem with the smart contract, which was basically the same. In order to deploy a new collection, we had to duplicate some code, change the supply, for example, the name, and we were ready to deploy. But for Sandbox, we audit all the contracts. And the auditing time takes up to 2 weeks. And that didn't scale. We almost delay some of the releases because of that. In order to fix it, we created a generic contract, as most of the mechanics of the contracts is the same. So we extracted all the common functionality into a generic contract, and when we create a new collection, we just extend that generic contract, and we are done. We're ready for production. But I will let Vlad tell you more about this.
Thank you. First, I want to mention that everything that we are doing on the smart contract development is free and open source. So you can use the generic raffle contract to deploy your own collection if you really want. Also, we did some contribution for the OpenSea royalty system in order to be fully compliant with their royalty system. And yeah, you can just grab the contract, deploy for yourself, manage the collection, and you're good to go. This generic raffle approach works for, I don't know, 5, 6 collections per year. But if you want to scale it up, you need to all the time have a technical person to deploy the collection, to deploy the smart contract, to manage the transaction, so on and so forth. So for that, right now, we are at the 3rd generation of a smart contract. We are auditing with OpenZeppelin Defender. And it's based on the factory patterns, so you just need a back office job. Every single non-technical person can deploy a collection just by signing some transactions. Good. Now that we are at the final part and the final problem that we identified and solved is the one of art scaling, so the art integration. In order to have 4 collections per month being created and integrated into the sandbox and more than 500,000 of avatars breach, you need a system that can generate the 3D models, the 2D representation of that 3D model, and the system that can integrate also the metadata. To illustrate a little bit of how why this is a complex problem, let's talk a little bit about the avatar in the context of Sandbox. So in Sandbox, an avatar is composed of three main components. First is the 3D model itself, and that has two more subcomponents, has the GLTF and the GLB file that can be easily distributed among different applications, like, I don't know, VR app, AR app, browser-based app. The second one is the 3D model that's used in-game, and that's a highly optimized format for our game maker and game client tool. Next, we are going to the 2D representation of that 3D model, which is used on OpenSea, on Twitter, everywhere you want a PFP, basically. And the last one are the traits. Okay, back a little bit, like last year, nobody really knew how to create collection, how to manage collections. There were like little tools, and we had this hard dependency on the 3D model itself. So we created a spreadsheet, basically, with a lot of Google Apps scripts on top of it, in which you can put your traits, you can set the scarcity for certain metadata, but the most important part is that you can map the trait visuals to the 3D nodes themselves. The result of this tool, you can see here, are all the tokens for the Playboy collection. It also has some exclusion rules, but the result of this tool is actually a package that can be imported by your voxel art team, and then they can create further the art. All right. After that, we had to also solve the 2D preview problem, and we created a bunch of glue code scripts that were run locally on our laptops in order to generate the 2D representation. Of course, you can see, you can imagine that this approach does scale. So we moved everything into a cloud-based pipeline. We had this, we called it the Cloud Pipeline tool. It's made up of step functions, AWS step functions, and those are gated by some API gateways, API endpoints. It has also a small UI, so non-technical people can access and can manage this pipeline easily. In this example, you can see here the Paris Hilton collection being generated. First, we receive the package from the art team. They are producing it in parallel of our development. We ingest the package. We generate the 3D models in parallel. We do the same thing for the previews, for the 2D representation. We pack everything together, and then we insert it in our storage. It's pretty efficient. If you change just one trait or just one model from your art, it doesn't regenerate the entire collection. It's going to generate just the part that was touched. Yeah, right now I'm proud to announce that it's managed by our staff. We managed to generate 500,000 of avatars with this tool in 2 days. So it's pretty scalable. Going further, we want to make all those tools, we pack them together, and we want to make them available for our landowners to be able to produce collections, but not only avatar collections, but collections of assets, of cars, of houses. And we are working right now to re-implement the spreadsheet and link it together with VoxEdit and the pipeline. So any landowner will be able to define the collection, traits, the package, and then hit a button and generate the collection. Yeah, so that's everything. If you have questions, let us know. Thank you.